Here's a problem that pre-training and fine-tuning can't fully solve. Ask a model how to get better at coding, and it might give you two technically correct answers that feel completely different in quality. One is crisp and actionable. The other wanders. Neither is factually wrong, but one is clearly better. How does the model learn what better even means? That's the problem RLHF was built to solve. Step 1 of RLHF is collecting human preference data. Human labelers, typically contractors trained on specific guidelines, are shown two model responses to the same prompt and asked, which is better, more helpful, more honest, less harmful? This is not a right or wrong task, it's a preference task. Thousands of these comparisons are collected and stored as a data set of human judgments. Step 2. Train a reward model. This is a separate neural network, smaller than the LLM, that takes a prompt and a response as input and outputs a single number, the reward score. A high score means the response is the kind humans prefer. A low score means it isn't. The reward model is trained on all those human preference comparisons until it can reliably predict which response a human would choose. It becomes an automated judge. Step 3. Use the reward model to train the LLM itself using reinforcement learning. The algorithm used is called PPO, Proximal Policy Optimization. The LLM generates a response. The reward model scores it. PPO uses that score to update the LLM's weights, pushing it to generate responses that score higher. But there's a critical safeguard. A KL divergence penalty that prevents the model from drifting too far from its fine-tuned baseline. Otherwise, it might game the reward model in bizarre ways rather than genuinely improving. What does RLHF actually change? Before RLHF, a model trained only on next token prediction might give harmful information simply because it appears in the training data. After RLHF, it declines appropriately. Before RLHF, explanations might be technically accurate but practically useless. After RLHF, they're concise, clear, and matched to what the user actually needs. This is the alignment layer. It's why talking to ChatGPT or Claude feels different from talking to a raw language model. And now you have the full picture. Pre-training gives the model knowledge of language and the world from 300 billion tokens of text. Supervised fine-tuning teaches it to follow instructions. The reward model learns to judge quality from human preferences. And RLHF uses that judgment to align the model's behavior with what humans actually want. Pre-training, fine-tuning, RLHF, that's how a text predictor becomes ChatGPT, Claude, or Gemini. If you've been following this series from the Transformer video, thank you. The next series starts with RAG, how AI answers questions about your own private data. Follow so you don't miss it.